Okay, so we're going to look at the definition of a function. Then apart from looking at that, we'll also look at the domain and the range of a function. We'll look at how to find the domain and the range of a function. And then apart from that, we also have to look at types of functions. There are different types of functions. Then apart from that, we'll look at the inverse of a function. Then from there, we'll look at the composition of functions. So I think the topic, the function, this topic is very short. If we manage to just look at these topics and if you manage to understand, it means that we're done with the topic of functions. The only thing that would remain with is just looking at the functions, the surds in short, in form of functions, the square roots like this. You have a surd like x squared plus 3, a function which is in this format. And then apart from that, we'll also look at the absolute value functions. And if at all it's part of your syllabus, we'll also discuss how to sketch these kinds of these types of functions. All right, so let's quickly begin the discussion. All right, so we'll first look at what a function is. So a function is simply just a binary relation over two sets that associates every element in the first set to exactly one or more in the second set. Okay, so a function is simply just a relation in short. When we talk about a relation, we talk about things which look like this. You may have maybe 1, 2, 3, then you have maybe 3, 2. Yeah, so you can have a function which is like this, which is, for instance, this one is being mapped onto that. Maybe 2 is also being mapped onto 3. You can have 3 mapped onto 2. Yeah, that is a function. So you can be told to generate the expression for this function. So a function, in other words, is just a mapping. Yeah, it's just a mapping which maps the first set to exactly one element in the second set. That's what we call a function. All right, so let's quickly begin to look at, okay, for instance, okay, these functions, they can also be expressed in different forms. Like I said, we have absolute value functions. We also have quadratic functions. We have linear functions. We have polynomials. We have exponential functions. So let us look at these types of functions. So an example of a function is simply just this. So mostly a function is denoted by f of x in most cases, but it can also be denoted by h of x, g of x, or any letter of x. That's a function. It can be denoted by any letter. Yeah, but in most cases, they use f of x, and then for polynomials, they use p of x. Right, so let's quickly begin to look at the types of functions. So we have the first type of function, which is called a linear function. So a linear function, like we learned in the previous session, a quadratic function has the power. The quadratic function is in this format. And remember, we said any function that has the power 1 is called the linear function. So any function that has the highest degree, which is 1, is called a linear function. So we can have such a function be called a linear function. Then this one is the one that we call a quadratic function. Right. And then we also have the constant function. So the constant function is, okay, let me also give you a sketch of what a linear function looks like. So a linear function will either come out like that, it will have a gradient, of course, or it will come out like that on the XY plane, or it can pass like that. That's how it is. These lines represent the sketches of a linear function. Then when we talk about a constant function, when we have f of x is equal to c, so this one is just a straight line that is parallel to the x-axis. So if you have your xy plane like this, x, then you have y there. So if you have c, there, if you have C there, it means that, yeah, if you have C there as your, what's this, as your, yeah, if you have C there as the numbers, the constant, what you normally do is, if you have this as your function, if you are drawing a sketch of a constant function, it's usually a straight line that is just parallel to the x-axis. That is the linear function. So you can have maybe, for instance, f of x is equal to 2. So this can be drawn as 1, 2. So this will be like that. So f of x is equal to 2. So that's a linear function, a constant function rather. So we move on to the next type of function. We have a quadratic function. So a quadratic function is the one that I gave as an example here. It's also exactly the same as what is here. This is also a quadratic function. Okay, we looked at quadratic functions in the previous slide, so I'm sure it's not a problem to most of you. And a quadratic function, when you sketch it, it will either face up or face down, depending with the value of the coefficient there. So if the coefficient is negative, in other words, if the coefficient, if the value of a in this expression, so if the value of a is less than 0, it means that it's going to have a maximum value. So it will come out like that. But if the value of a is greater than 0, the value of a is greater than 0, it means that when you sketch it, it's going to have a minimum value. That's what it means. So from there, we can also discuss the exponential function. So this is an exponential function. So exponential functions, if you sketch them, to either come out like that or to go like that. Yeah, so this is basically how they look. Yeah, so that is what we call an exponential function. Okay, then we also have another type, which is a polynomial. So a polynomial is simply just a function that has a degree that is greater than 1, that has the highest degree which is greater than 1. So in other words, a quadratic function is also a polynomial with a degree 2. Poly means many. Poly means many. So if we say a polynomial, we're simply referring to a function with a degree that is more than 1, that is greater than 1 in short. We also have what is called a rational function. So a rational function is simply just a function that is in a fraction form. You can have x squared plus 1 over x plus 2. This is a rational function because it is in the fraction form. And the denominator is never equal to 0. So the denominator is qx, and there is the definition. Remember what we do, how we defined rational numbers. The denominator was never equal to 0. We had said a rational number is simply just a number that is in the form a over b, where a and b are members of integers, and b is never going to be equal to 0. And of course, a and b should be their lowest term. So when we say b is never equal to 0, we simply refer to the denominator. The denominator should never be equal to 0. So in this format, we have qx as the denominator. Hence, qx is not supposed to be 0 for this to be called a rational function. So we also have what are called a modular function. So modular value function or modular function are also called absolute value functions. So these absolute value functions, they are always in the format f of x is equal to absolute value of x. You can have any function, either a quadratic, polynomial, you can have a linear equation, as long as it has absolute value functions, rather absolute value symbols. you call it a modular function or the absolute value function. All right, so let's look at the domain and the range of a function. So how do you find the domain and the range? So you have been given, okay, let me first start by defining what a domain is. So a domain is simply just any input or any number that you put in a function. That you put in a function, in short, that number is called the domain. So the domain of a function is a set into which all the input of the function is constrained to 4. So it is a set X in the notation f of X is equal to Y or is mapped onto Y. So if you have two sets like this, you have 2, 3, 4, and then you have 1, 2, 3. Then you have these numbers being mapped onto the, so we have the first set of X, we have the other set of f of X. So this set of X is the one that we call the domain. So these numbers that we're using is the one that we're using to find f of X are the ones that we're calling the domain. So if you have, let's say for instance, f of X is equal to 2x, and then they ask you to find f of 2. So f of 2 is simply just found by replacing what is X, you put 2 there, hence this becomes 4. So this 4 is called the range. So now the 2 that you had put in to find the range, which is 4, is the one that we call the domain. So any input into the function is called the domain. So let's look at the range. So the range is just the opposite of the domain, which is just the output or the outcome or anything that you output or anything that you find after inserting the domain into the function is called the range. Okay, let's look at some of the examples. For each of the following functions, list its domain and the range. So you have the first function here. So in the first function, the set of the domain will simply just be given by, you just get the values of X. So we have 1, 2, and 5. This is the domain. Then to find the range in this expression is simply just equal to the set of the output. So we have 5, 9, and 21. 5, 9, 21. So this is what we have. This is what we have. And then in this expression, we do the same. The domain in that expression is simply just 0. We just get the sets, the inputs 0, 2, -1, and -2. 0, 2, -1, and -2. And then the range will simply just be equal to, so the range will simply just be equal to the set of outputs. We have 0, 8, -1, -8. We have 0, 8, -1, -8. So this is exactly what you're supposed to find if such a question was to be given to you. Okay, let's look at the other thing, which is just the other way of finding the range, in short. So we've been given this function, which is g of x. So g of x is simply just equal to x squared minus 4. So x squared minus 4 is g of x. So let us now find f of, rather, this was supposed to be f, not g. So let us find f of, so let us find f of 2. So this is f of x is equal to that. So we find f of 2. So f of 2 is equal to, we just replace 2 while there's x. So while there's x there, we're going to put 2. So we have 2 squared minus 4. So f of 2 will simply just give us 4 minus 4, which is just a 0. Then f of -1. F of -1 will simply just be found by replacing -1 while there's x there. So while there's x, we put -1 minus 4 there. So we have -1 squared is simply just +1 minus 4, which is just -3. So this is how you find f of any number. It's just as simple as that. All right, so how do we now find the inverse of a function? So the inverse of a function is very straightforward. Yeah, so the inverse of a function is very much straightforward. And it's a very important tool that is used to find the range of any function that has been given in this format. So without knowing how to find the inverse, it will be difficult for you to find the range of this function here. So let us see how simple it is to find the inverse of a function. So the inverse of a function is denoted by f inverse of any letter there. We can have x. So if we have f of x as the function, to find the inverse, the inverse of f of x would be denoted by f inverse of x. If we have g of x as the function, the inverse of g would be denoted by g inverse of x. If we have m of x as the function, the inverse function of m will be denoted by m inverse of x. This is how you denote an inverse function. So let's look at an example. You have this example to say f of x is equal to 5x minus 9. Then find the inverse of this function. So the inverse of this function is simply just found by first equating f of x to y. So we say let y be equal to f of x. So meaning while there's f of x there, we can replace with y. So I'm going to say y will now be equal to that. So y will now be equal to 5x minus 9. So y will be equal to 5x minus 9. So now here it's just a matter of us. It's just a matter of us making x the subject of the formula. So how do we make x the subject? We take this 9 to the other side of the equal sign, and hence we're going to have 9 plus y plus 9 is equal to 5x. So when we divide everything by 5, the value of x now becomes y plus 9 over 5. So this is how you find the inverse of a function. Hence, while there is y there, we can replace with x. And then while there's x, we put f inverse of x. We say hence f inverse of x is equal to, while there's x there, while there's y there, we're going to put x, and then we have plus 9 there, then everything divided by 5. So this is the inverse of this given function here. So it's just as simple as that. The first step, you just put y while there's f of x, and then from there, you make x the subject of the formula. Once you make x the subject of the formula, while there's y, you come and replace with x, and then while there's x, you come and replace with f inverse of x. So that is exactly how you find the inverse function. So another example. Yes, Mary, you have a question?
So on the functions, when you cross that 5 to the other side, it doesn't carry a negative sign or a positive sign, just remains like that.
The function, the expression was y is equal to 5x minus 9. So when I take this 9 to the other side of the equal sign, it's going to be y plus 9. Is it, you've seen, huh? All right. Yes, so this 5, even if I take it this side, it will not carry a sign because, yeah, I'm sure you understand. Yeah.
Yes, I do. Thank you.
All right. You're most welcome. All right. So we also have these examples here. So I've solved the first example there. Let me now solve this one and this one. So for each given function, find f inverse of x. So I'm just going to start with b. I'm just from solving a. So I'm going to start with b. So we say b is just f of x is equal to x minus 3 over 2. So we say let y be equal to x minus 3 over 2. So now, after making y being equal to this, we are going to make x the subject of the formula in this expression. So making x the subject of the formula, we're going to cross multiply here. So we say y times 2, you're going to get 2y is equal to, then this 1 times everything there, which is x minus 3. So when you multiply 1 times everything this side, you have x minus 3 as the answer. Then making x the subject of the formula, you just take this negative 3 to the other side, and hence you have 2y plus 3 is equal to x. And what you now have to do here is change x. You change this x and make it f of x. And then while there's y there, you just have to replace with, while there's y there, you just have to replace with x. So we are going to say, or let me write it in this way. We have x is equal to 2y plus 3. So while there's x, I'm going to put f inverse of x. And then while there's y there, I'm replacing with x. Hence, I'll have 2x plus 3. So this is the inverse of this given function there. So when you have this kind of a function, that is C, part C. So part C, you also say let y be equal to x to the power 3 plus 1. So you also do the same, make x the subject. We're going to take the 1 to the other side of the equal sign. So we have y minus 1 is equal to x to the power 3. So to get rid of this power 3, we're going to introduce the cube root on both sides. So let me write it this way. X to the power 3 is equal to y minus 1. So we say the cube root of that, and then the cube root of that. So the cube root of x to the power 3 will just be x. And then the cube root of that will just remain that, the cube root of y minus 1. Hence, f inverse of x will now therefore be equal to the cube root of what is y, you put x minus 1. So that is the answer. So that is exactly what we are supposed to do when you've been asked to find the inverse. All right, so let us look at the composition of functions. So, okay, Linda, you have a question? You can ask.
Kindly just go through again on the third example. See, just kind of go through.
Okay, so the third example, let me just erase this part. Okay, so the third example is a very simple and straightforward example. Okay, so what I said is that this is the function here. So you just say let y be equal to the function that we've been given, which is x to the power 3 plus 1. So what we do to make x the subject of the formula, to make this x the subject, we just take the 1 to the other side. Hence, we're going to have y minus 1 is equal to x to the power 3. So what you have to do now to get rid of this power 3, you simply just introduce the cube root on both sides. Or if you don't want to introduce the cube root, you just say y minus 1 to the power 1 over 3 is equal to x to the power 3, and then you raise everything to the power 1 over 3. So when you do this, when you multiply this 3 times 1 over 3, you get 1. So this would be x to the power 1, which is just the same as just x. Then this side, you're going to have y minus 1 to the power 1 over 3. Yeah, so to write this, you're going to have f inverse of x is equal to, while there is y, you put x. This will be minus 1 to the power 1 over 3, which can also be written as, because we know that any number raised to the power 1 over 3 is simply just the cube root of that number. Hence, I can write this statement as f inverse of x is equal to the cube root of x minus 1. So this is what you do. Okay. So let's quickly look at the composition of functions. composition of functions. So when you hear about composite functions, these are just functions which have been put into another functions. So for instance, if you have f of x, and then which is equal to 2x, then you also have g of x, maybe which is equal to x plus 1. Then they ask you to find f of g of x. So how do you find this? It means that in this case, we can write this f of g of x as f of g of x. So when we write it like this, remember what we said. We said if you've been given f of x like this one, then they ask you to find f of 2. F of 2, it means that while there's x, you're going to replace with 2. So you're going to have 2, and then while there's x, you put 2, and then hence you find the value as 4. Your range or your answer is 4. So even in this case, while there's g of x, we're going to put this expression. So in this function of f, while there is g of x, we're going to put x plus 2. So rather in this function, in f, while there's x, we're going to put g of x. So this is just the same as saying, so f of g, let me do this, f of g of x. So this one is just the same as, so this one is just the same as 2, while there's x, we put g of x. So I'm going to say 2 times g of x. So what is my g of x? So my g of x is simply just x plus 1. So I'm going to put x plus 1 there. So when you simplify that, you get 2x plus 2 as the answer. Right, so this is exactly what you are supposed to do. So if they interchange it, they say find g of f of x. So this one is just the same as in g, while there is x, we put f of x. So g of f of x will therefore be equal to, so g of f of x will now be equal to, while there's f of x, I'm putting, rather while in g, while there's x, in g, while there's x, I'm replacing this part with f of x. Hence I'm going to have, while there's x, I'm putting f of x, then I'm going to say plus 1. So what is f of x in this case? The f of x is simply just 2x. So I'm putting 2x there, then plus 1. So this is g of f of x. So these are what we call composite functions. Right. So simplest definition of a composite function is simply just a function within a function. So examples of these functions are these. So it can be given like what I was just from illustrating. You can be given this expression. Say, you have f of x as this one, then you have g of x as that one. So if f of x is this one, they ask you to find f of f. So f of x, this one is simply just the same as in f, while there's x, I'm going to put f of x. So in f, while there's x, I'm going to put f of x. So in f, which is this one, I'm going to put, while there's x, I'm putting f of x. So I'm going to say f of x plus 6. So I'm trying to find f of x. So I'm going to say f of x plus 6. Hence, what is f of x? F of x is x plus 6. So I'm going to put x plus 6 there. Then I'll put plus 6 this part. Hence, the final answer will be x plus 12. Hope this is clear. So same applies to the other expression. So let's say you have, they ask us to find f of g of x. So this one is just the same as in what's this? In the function f, while there is x, we're going to put g of x. So this is just the same as writing it like that. And hence, this is going to be equal to, so in f, while there's x, I'm putting g of x. Then we say plus 6. So what is g of x? G of x is x squared plus 3. So I'm going to have x squared plus 3, then plus 6. So x squared, we have it there. Then 3 plus 6, this is just 9. This is the answer for the second part. So when we have g of f of x, so g of f of x is simply just the same as g. While in g, while there is x, I'm putting f of x. So in g, while there's x, I'm putting f of x. So g is simply just x squared plus 3. So this is just the same as f of x squared plus 3. So what is f of x? F of x is simply just x plus 6. So x plus 6 squared. So x plus 6 squared, then we have a plus 3 outside. So when we simplify this part, we're going to have x squared plus 12x plus 36. When you do the simplification there, then you have plus 3. Then you are going to get the final answer as x squared plus 12x, then plus 39. So this is the value of g of f of x. So the other expression that they want us to find is g of f, rather g of g of x. So this one is just the same as saying, this one is just the same as saying, in g, while there's x, we put g. In g, while there's x, we put g. So this is just the same as saying g of x. Sorry, this one is supposed to be g. So in g, while there's x, we're replacing with g of x. So in g, while there's x squared there, while there's x there, we put g of x. So we're going to have g of x, then squared, and then we have plus 3. So what is g of x? G of x is simply just x squared plus 3. Then we're squaring this, then we have plus 3 there. So from there, we can now simplify this. So we're going to have x to the power 4 plus 3, rather, when we do the simplification, we're going to have plus 6 x squared, and then plus 9, then plus 3. So when you finish everything, you simplify it to x to the power 4, then plus 6 x squared plus 12. So this is our g of x. All right, so this is how you deal with composite function. Yes, Linda, what's your question?
That's 6x squared. Where is it come from?
All right, so let's just do it bit by bit in the remaining few minutes. And then I think we'll end here. I'll give an exercise so that I see if you've understood what we've learned so far. The next time we'll start from even, odd, and neither functions, neither even or odd functions. Okay, so this one here, when you have been told to simplify this, this is just the same as x squared plus 3 times x squared plus 3. So this expression is multiplying itself 2 times. Then we have a plus 3 outside. So now when we multiply this times everything in the brackets, that's the same as saying x squared times x squared plus 3. Then you have plus 3 times everything there. This 3 again multiplies with everything in this bracket. So you have x squared plus 3 there. And you have plus 3. So we say x times x squared times x squared. This is x to the power 4. X squared times 3x, times 3. We're going to get 3x squared. 3 times x squared, we have 3x squared. And then we have 3 times 3, we have 9 plus 3. So when you do the simplification there, we have x to the power 4. So x to the power 4, and then here we have 3x squared plus 3x squared. We're getting 6x squared. This is where it came from. Then we have a 9 there. And I remember this is the mistake that most of you make when I give you an exercise. I'll make an emphasis immediately after this. So we have plus 3 there. So we have x to the power 4 plus 6x squared plus 3 plus 9. The answer is 12. So please look at what I'm going to write here. When I say x plus 1, let me even put a 2 there. When I say x plus 2, and then in brackets squared, this is not equal to x squared plus 2 squared. They are not equal. This is mathematically wrong. These two here are not equal. So what this means is that you have to multiply these 2 times. This is what it means. So when I say x plus 2 raised to the power 2, you have to make sure that you write it in this format. And then you begin to multiply this x multiplied by everything there and 2 multiplied by everything there. So you say x open brackets, x plus 2. And then you have plus 2 open brackets, x plus 2. Then you multiply x times x, x squared. X times 2, you have 2x. 2 times x, you have 2x. 2 times 2, you have 4. And then when you do the simplification, you're going to get x squared plus 4x plus 4. This is what it means. So never make a mistake to write this as equal to that. They are not equal. They are not equal. These two cannot be distributed into the brackets. No. All right, the time is even up. So if you have a question, you can text me on WhatsApp. If it means me coming back to explain your question, feel free. Okay, the time is up. All right, so we're going to switch to ICT very soon. Thank you very much for attending tonight's lesson.